So today we are going to be talking about advanced PDL capabilities. Previously you've probably seen other functions, things like phrase, follow, near, sentence. So you should be familiar with these functions already, and we've covered these probably before. Other functions here you might not have seen before, things like paragraph, line, fnear. That's okay. The point is there's a lot of different functions that can cover proximity. So proximity functions like phrase and near have some parameters. They can look for words within a certain distance of each other. This distance depends on the function we're using. So with a function like phrase or near, that's measured in words. But if we're looking at something like sentence or follow, that distance is going to be measured in actual sentences. But the point is pretty much the same. We're measuring distance between our words. Now, some functions have additional parameters or additional constraints they want to place on a query. So, for example, phrase, there's an ordering constraint, and then there's also a constraint that the words in our query have to be part of the same sentence. So both of those constraints are present in the phrase function. But those constraints could be absent in other functions, or maybe one of them is, but the other isn't. So all these functions kind of do very similar, but slightly different operations in our queries. And they're all just looking at proximity. Today, we are going to be moving on to some more advanced functions. So, the problem with proximity functions is they're only approximating these relationships. If we have a complicated piece of text, maybe this proximity is not going to be good enough to capture what we're looking for. For many cases, it's okay, but sometimes there's something very specific going on in our language, and we need something more advanced to capture that. So these advanced functions inside of PDL access linguistic parsing. So what you're looking at right now is kind of a visual diagram of what's going on in the text at a deeper level. So this is an example of dependency parsing. So in here you'll see different words having different relationships with other words. And that relationship is designated with an arrow going from one word to the other. And that arrow is labeled with the type of relationship that's going on there. So, for example, we have customer states that there's an object relationship between states and the word that. At the bottom, you'll see other labels, things like modifier or subject or predicate. Those aren't the dependency parsing that we see at the top, but they're something related to that. They're sort of like an approximation. So these are the things that we'll be using to create more advanced. The functions inside of polyanalyst that we'll be using for these advanced queries are dependency and dnode. The dependency is going to be more general. It's not using the most advanced parsing. Actually, it's using the approximated version that we saw at the bottom. But it's easier to learn, it's easier to use, and it can also be a little bit more accurate for very simple sentences, especially if we're not using proper grammar in that text. dnode, on the other hand, is going to be a lot more precise in what it's looking for. And it can be more precise because it's using the full dependency tree. It's looking at the most detailed parsing of our sentence. Now, dnode is like a scalpel. It can be very precise, but sometimes it can be too precise for what we're looking for. So, with a lot of power in dnode, there comes some cost because it can be a little bit more complicated and it might not be as generalizable as something like dependency can be. So there's pros and cons of both of these functions. For this video, we'll be talking about dependency, Check out our next video to learn more about dnode. So why do we need these functions in the first place? I've talked about proximity functions and how they might not work. Well, how can they not work? So here's an example. So we have a few different pieces of text. Sales are increasing. Sales facing increased pressure, and so on. And maybe we'd like to look for cases where the sales are increasing. Sales are on the rise. Sales are going up, etc. How would we construct a PDL query to look for this? Well, we could use something like sneer. This is just near with a sentence function wrapped around it, or in other words, it's just the near function, but it's also adding a constraint that the words have to be in the same sentence. So let's look for that. Let's look for increase close to the word sales and in the same sentence. Well, sales are increasing. Good, that can be captured. Sales facing increased pressure. Well, semantically, sales aren't the things increasing here. So it's not really what we wanted, but it will be still matched by this PDL query we created. So that's not good. Increase in sales are terminated. Again, semantically, that's not what we want. The increase in sales is still, it was terminated. There is no increase in sales, but because of this proximity argument, we're still capturing that. And then finally, sales for the sugarcane division are expected to be increasing in 2008. Well, the word increase and the word sales are too far apart, so they won't be matched by our query, but we wanted that to be matched here because the sales are expected to be increasing, and we did not match that here. So we matched one of these. Two of them we shouldn't have matched, but we did, and one of them we should have matched, but we didn't. So there's some issues with just relying on our simple proximity function. Now, I'll show you how to use the dependency function, which will allow us to capture all of these. So if I use the dependency function here, I can actually find the first and fourth one without worrying about the middle two, and we'll see how we can use this. So first of all, we need to understand some kind of a breakdown of the actual sentences here, the actual parsing. So like we said earlier, the s near, phrase, etc., those are just based on positions of the words. The dependency function is based on relationships between, maybe not words themselves, but parts of sentences. These are called syntactic analyzer tags. So we have some parts that are called predicates, like facing. We have some parts called subjects, like sales. And then we have other things like pressure, which are objects. And then finally we have modifiers. Sales facing increased pressure is a subject predicate modifier object. And then we have relationships upon which are between these tags. And different parts of speech have different types of directional relationships. So we can kind of view this as a table like this. So, for example, if I have a subject, the relationship between a subject, in other words, would be a predicate-subject relationship. So it goes from the predicate to the subject. And that ordering, that directionality there is very important to remember, or at least know that there is some directionality involved there, so you can refer to the manual or these slides or this video to understand the correct ordering. And that ordering is just agreed upon by linguists, and so it might seem unintuitive at first, but from a linguist standpoint, it's actually proper. So in this case, going from the predicate to the subject, she will leave tomorrow. Okay, she will leave is an example of that relationship. The predicate will leave as a relationship to the subject she. Will leave is the action there. It's the verb. And who is doing that verb? It's the subject, she. That's why there's a relationship from the predicate to the subject. Or there could be a relationship from the predicate to an object. I don't know his phone number. So there's a predicate, don't know. Don't know what? What is the thing that is not known? It's the number. So there's relationship from don't know to number defined as an object relationship, going from the predicate to an object. And then there are various other types of relationships. So one more I might mention is the modifier relationship, going from a subject to a modifier or an object to a modifier. So political news. There's news. What type of news? What is modifying that? It's political news. So it goes from the subject to the modifier. And so we might intuitively think of it going from the modifier to the subject, because usually the modifier comes first. So we might say political what? Political news, but that's not how it's actually working linguistically. It's news. What kind of news? Political. Or markets. What kind of markets? Currency markets. So from markets to the modifier currency. So these are the types of relationships that we are modeling with the dependency function. We have parts of speech that we have labeled under the hood, and that's done automatically for you. And then you can call upon the dependency function to find things that match relationships between these different tags. So the basic syntax of the dependency node is as follows. We'll call the dependency function like we would any other function. We'll open a set of parentheses, and then we have several different types of arguments. We have the dependency type argument, and then we'll have a number of syntax relationship arguments, and then we'll have a number of terms. If that's a lot taken at once, don't worry about it. We'll kind of ignore several of this for now and kind of build onto it later. So the syntax relationship argument, that central argument there, that's going to be something like subject, or you can abbreviate and use SBJ, object, OBJ, etc. This is going to just define the relationships that we saw. And this is the same thing we saw earlier. So instead of that part of speech column, we'll have this syntax relationship column. So if you'd like to look for a predicate to subject relationship, like she will leave, you will like to use subject as that argument. Or if you want to use a subject to modifier, like political news, you would use a modifier argument for the syntax relationship. So here's just an example. Some of these things are completely optional, like that syntax relationship argument. That's going to be optional. If we don't include that, it'll just look for all of them. So I can use dependency and then announce agreement as two terms that I'm interested in. So this will look for cases where there's a relationship between announce and agreement. So the agreement was announced. Yeah, there's an agreement and it was announced. That's a relationship there. The company's board expects to announce a definitive agreement on the sale this week. That is also captured. The agreement forced the board to modify the law, which was announced yesterday. This is not captured because there's not a relationship between agreement and announced. The agreement forced the board to modify the law, which was announced yesterday. Well, the law was announced. So in this case, the relationship there's no relationship between agreement or announced. Now I can also give it a different type of actual relationship here. In the previous dependency announce agreement example, we didn't specify what type of relationship. We didn't use that syntax relationship argument. So now I'll provide one to it. I'll use the subject relationship. And so now there has to be a subject predicate subject relationship going on here. So in this case, it'll match the first one. Why? It's going from the predicate to the subject. So from announce to agreement. So the agreement was announced. Something is announced, okay? What was announced? The agreement. The agreement here is the subject of that announced predicate. So you have to think of that relationship again. Remember, it had a directionality from the first thing to the second thing. That explains why the second one will not be picked up by this query here. Because the relationship has to go from announce to agreement, in this case, the company's board expects to announce a definitive agreement. Well, here, it's the other way around. Announce and agreement don't have this predicate-subject relationship in that ordering. And then finally, this third one, again, there's no relationship at all between these two here. So it's, once again, not being matched. So we've seen how we can add this syntax relationship argument. We'll look at some more examples here. So the company's board expects to announce a thoroughly modified and more comprehensive agreement. It's a long sentence, but this dependency function is still able to capture it because there's that relationship between announce and agreement by an object type. The predicate announce is going to be linked to the word agreement with an object relationship. The agreement is the object of that predicate there. You're announcing something. What are you announcing? You're announcing the agreement. So this long sentence can be matched pretty easily with the dependency function. If you wanted to do this with phrase, for example, it'd be very difficult because you'd have to have a very long parameter there, very large parameter for the distance, and that could give us a lot of erroneous results. So what if we want to look for something different, a modifier? So we want a bigger and better supermarket. That's going to be captured because it's going from supermarket to bigger. So what kind of supermarket? A bigger supermarket. That's that relationship there. And then we have, various other types of relationships. Signed when, signed tomorrow. So here's a tricky example. We have dependency, subject, count, wake, and we have a wake counts as a funeral, and the count is waking up. In this case, the relationship is captured. So in here, we're going from count to wake. So something counts as something. So what counts? A wake counts. Okay. And then we also have the count is waking up. In this case, we also have a relationship from wake to count. Waking is the predicate here, and count is the subject, and so it'll be matched. The order we presented these words in didn't really matter. We just wanted to know if there's a predicate to subject relationship here. So either if it's from count to wake, that's fine, or it's from wake to count, that's also fine, as long as it's defined by this subject relation type, from a predicate to a subject. But what if we don't want this? Well, if we want to specify ordering, and only the ordering we provide, we can give that as another argument. So here we're giving it the argument forward. In this case, it'll count the first one from count to wake, but it won't capture the second one because it can't go from wake to count. It must go forward along our path from count to wake. If I wanted a wake counts as if I wanted the count is waking up, so from waking to count, but not a count but not a wake counts, I would have to do dependency forward subject wake count. So we're very inclined to think linearly along the sentence when we're trying to analyze these. So sales facing increased pressure. That's the way we kind of naturally want to think. But to help create these queries, understand what's going on in the actual dependency syntax of our speech, we should be thinking more like a tree diagram. So start at the predicate, facing going to sales, okay, that's relationship. And then we're going from facing to pressure, that's another branch. And then from pressure to increased. So facing, there's that predicate, it's kind of like the root of our sentence. And then from that verb and that predicate, we're getting other pieces of information. We're getting the subject of that predicate, we're getting the object of that predicate, and then that object had a modifier attached to it as well. So when you're writing these queries and trying to understand what's going on, think of it as a kind of a tree diagram. Do the kind of parsing. You might have to diagram it a bit if you're not used to doing something like this, but that's fine. But thinking kind of in this tree structure will help you understand what's going on in these queries a lot better, because they can be a little bit complicated if you're not used to thinking this way. Now, there's a lot to remember sometimes, but you don't really always have to remember all of it. You don't need to remember the ordering constantly. You just need to remember that the ordering matters. So if you forget if it goes from predicate to the subject, just know that ordering matters, and so you should refer to this table, for example, to know that it's from the predicate to the subject. As long as you know that there's an ordering there, and that ordering matters, you can refer to documentation as you're learning to use these functions. Then after a bit, you'll just remember, and you won't need to reference them anymore. So we've seen all the components of dependency syntax so far. We've seen terms, announce, agreement, count, wake. We've seen the syntax relationship. It's a subject relationship, an object relationship, a modifier relationship. And then we've just introduced this dependency type, whether it's forward, as we saw previously, or bidirectional. So if we have bidirectional, forward, and tree, these are different possibilities here. For bidirectional, it's just going to be between any of the terms. It doesn't really matter. This is just if you don't provide dependency type, this is just the default setting. Now forward, like we saw, has to go from the first term to the second term, and then from the second term to the third term, all the way down the branch there. So it has to go in this just forward direction. And then a tree structure, my first term will be matched to my second term, and then my first term will also be matched to my third term in that directional. So it's like this branching tree structure. So here's some examples. We have two sentences. The sedan was light green, and can you see the green light? So if we use the dependency modifier light green, by default this is going to be bidirectional, so it can go from light to green or from green to light. So in this case the sedan was light green, so green goes to light, and then can you see the green light? Light goes to green. So both of those are being captured because it doesn't matter the directionality as long as it goes from one to the other in this case. But if we impose the forward directionality there, it will only capture two. It has to go from light to green. So the light is the object there, and green is the modifier. So it's from the object to the modifier. Again, it's sometimes unintuitive. Or if I use the dependency forward and then I switch the order there, it goes from green to light. So dependency forward modifier, green, light. I need to go from green to light, so I'm only capturing the first one there. So let's take a look at this tree modifier. Dependency tree, subject, object, announce, company, agreement. So what's going on here? Well, I need to go from announce to company, and that's defined as this predicate to subject relationship by that first argument there we have in the box. And then I also need to have relationship from announce to agreement because of the tree structure. And that is going to be defined by the predicate to object relationship. So, company expects to announce a definitive agreement. So we have the predicate announce. The announce is a part of a predicate here. The subject of that predicate is company, and then the object of that same predicate is agreement. This is a very common structure. We'll use the tree structure, subject-object. So we'll have a verb, the subject of the verb, and then the object of that verb. It's a very common query structure. But dependency, we've seen some powerful examples of it, but it does have some limitations. So here we have expected to be increasing. What if we wanted to look for something like it's like that? Like we want it to look for where it's expected to be increasing. How would we use dependency here? Well, we can't, because they are both inside a predicate. If both of our terms are inside the same word group, like a predicate, we can't use the dependency relationship because there's no dependency relationship from a predicate to another predicate or from a predicate to itself. There's no way to use dependency in this case. But don't worry, we'll move on and we'll talk about a more advanced function called dnode. This is going to allow us to have a little bit more of a focused query. It's going to be a lot more of like a scalpel versus dependency.